China's artificial sun raises concerns in the West over energy dominance. Western governments and investors have spent the past week grappling with a series of groundbreaking scientific advancements emerging from China. Just days ago, the artificial intelligence company DeepSeek burst onto the global stage, challenging America's dominance in AI and triggering market turbulence, national security reviews, and data concerns among officials. However, another significant development has flown somewhat under the radar. China's latest leap in nuclear fusion research. Recently released satellite images over Mianyang, central China, reveal a massive X-shaped structure with 4 protruding wings, which experts believe to be a laser nuclear fusion research facility. According to analysts at the CNA security think tank, the facility is designed to fire high-powered lasers at a central chamber, heating fuel pellets to 100 million degrees Celsius, mimicking the sun's energy-producing process. This approach, known as laser-ignited fusion, plays a crucial role in nuclear weapons simulations, but is also a potential breakthrough in the pursuit of limitless clean energy. If successful, nuclear fusion could provide an unparalleled source of green, reliable power. China's fusion ambitions: catching up or overtaking? Until now, the United States has led the global race in fusion technology. In 2022, scientists at the Lawrence Livermore National Laboratory in California achieved a historic milestone, generating more energy from a fusion reaction than was required to ignite it. However, China's new Mianyang facility appears to be 50% larger than its American counterpart, raising concerns that Beijing may not only be catching up, but could soon surpass the West in nuclear fusion capabilities. A key indication of China's commitment to this technological race came last week when the Chinese Academy of Sciences announced that its scientists had sustained an artificial sun, a fusion reactor simulating the sun's core, for 1,066 seconds. This shattered previous records and demonstrated China's accelerating progress in the field. State media widely celebrated the achievement, publishing images of the donut-shaped tokamak reactor with a prominent Chinese flag displayed on top. Fusion: the key to limitless clean energy. Unlike nuclear fission, which splits atoms to release energy, fusion combines hydrogen atoms to create helium, unleashing vast amounts of energy in the process. While the sun naturally sustains this reaction due to its immense gravitational force, Earth-based reactors must recreate these conditions using extreme temperatures and powerful magnetic fields. If fully harnessed, fusion could provide virtually infinite energy, without the radioactive waste and safety risks associated with nuclear fission. However, despite decades of research, no country has yet achieved commercially viable fusion power. China's strategic edge: a well-funded, coordinated effort for decades, nuclear fusion has been a scientific aspiration, with Western nations leading most research efforts. However, China has invested billions in the past 25 years, positioning itself as a major contender in the field. They are making tremendous progress, says George Barovas, a nuclear energy expert and board member of the World Nuclear Association. They see nuclear, both fission and fusion, as a major national priority. It's a highly coordinated effort. China initially gained expertise in fusion through collaborations with the West, particularly after joining the World Trade Organization, WTO, in the early 2000s. In 2003, China became a key participant in the International Thermonuclear Experimental Reactor ITER project, a massive France-based fusion initiative dating back to the 1980s. However, ITER has faced major setbacks, with its launch repeatedly delayed, from an initial target of 2020 to at least 2034. Critics have labeled it the most delayed and cost-inflated science project in history. In contrast, China is now developing its own alternative, the China Fusion Engineering Test Reactor, CFETR, which is expected to be operational by 2035, potentially outpacing the European-led ITER project. Experts argue that while Western fusion efforts are fragmented, China's centralized, well-funded, and highly ambitious strategy gives it a competitive edge. Chinese fusion scientist Xianzhu Gong illustrated this relentless drive last year, telling Nature, "Almost no weekends, no holidays for us." The fusion race, China versus the West. The global race to master nuclear fusion has intensified, driven by two factors. 1. Net zero climate goals, which demand clean and sustainable energy sources. 2. The rise of artificial intelligence, AI, which is expected to consume up to 25% of U.S. electricity demand by the end of the decade, according to tech industry leaders. A Washington-based report from the Information Technology and Innovation Foundation found that while the U.S. and